I am Stephen Curtis from Amazon Web Services, the track chair for the developer track in Hall D. I have the great pleasure of introducing 3 colleagues for the next session that I work with on a daily basis. Josh Burns, who is sort of the technical leader and voice for spatial computing at AWS. Kellen Cartledge, who is our photogrammetry and NVIDIA Omniverse expert. And Lauren Marble, there you go. Who is a colleague on my team and brings a great technical and mathematics depth to our XR capabilities. And their session, AWS Spatial Building Blocks of the Metaverse. So please welcome them on stage.
Thank you for that glowing representation, Stephen. It's always awesome working with you, bud. All right, welcome everybody to AWS Spatial Building Blocks of the Metaverse. Now, first thing I want to ask, this is for the builders in the room. Where are my devs? Okay, we're all introverts. You don't have to raise your hand. It's okay. Now, what we're going to talk about today is how do we scale XR applications utilizing AWS and things that we can provide for you. Real things you can use today. So we'll go ahead and get started a little bit. We're going to first talk about scaling visual data with spatial data planes. Then we're going to talk about utilizing photogrammetry within 3D pipelines. And lastly, the power of AI/ML utilizing AWS for pipelines itself. So first, a 3D model is worth 1,000 pictures. There's something we caught Warner Vogel saying last year at our reInvent sessions. He's our Chief Technology Officer. Freaking awesome to kind of see this type of stuff. But we're excited to power spatial situations and spatial experiences utilizing AWS. So first off, scaling the data. This is one of the primary challenges we see within AWS when we work with our customers. The majority of us are prototyping architects, so we're building spatial AR, VR, 3D experiences for the enterprise. So we interact daily with customers that are building the next generation ideas, including Spot, who's entering the back of the room. Thanks, Kamate. But we're looking at how we integrate AWS services in such a way that we can interact with them utilizing the cloud and scaling those applications to create a greater return on investment for our customers. So we have a concept called spatial data lakes, where an individual organization may store all their data within a given application or given infrastructure that is unique to their organization. Now, I want to expand that further to you and introduce you a spatial data plane, where we can organize multiple 3-dimensional assets, AI/ML algorithms, or other IoT data, utilizing a singular identity or a multitude of identities of an individual to grab those data points from different pieces so you can render them on a device, basically creating a consensual metaverse, a consensual data experience that you don't have to share all the data with everybody around you, but unique pieces that they have permission to. And this is something I'm very excited about building. However, we already have the first piece today, which is those spatial data lakes. And if you're going to call me on it, here's the code. We open sourced this back in November. This is something we call the Visual Asset Management System. This code is available for you today to deploy on AWS. So developers, I'll talk to you a little bit about what that is. And if you need that later, come talk to me. We'll get you navigated there. So what the Visual Asset Management System does is it creates a spatial data lake that stores, manages, distributes, and transforms your data that you may store on AWS, whether that is CAD files, whether that is manufacturing files, or whether that is media and entertainment files, videos, JPEGs, you name it, that you want to utilize in your spatial experiences. And then we allow for you to distribute at runtime, at scale, to a multitude of applications. So if you compile that app, all you have to do is call an API to get the updated asset, whether you're using Unity, Babylon.js, or Unreal, or 3.js. So a combination of WebXR assets or game engines. That way, a single asset can be distributed to a multitude of applications. Now, you heard me talk a bit about transforms. Well, we call those pipelines. A singular pipeline is what you see here. And we use containers to perform basically complex or simple conversions. And utilizing VAMs today, you can string containers together to basically take an output, such as a CAD conversion to GLTF. Then you can tessellate that file. Then you can optimize, light baking. You can script the entire interface. So instead of having one artist do one job a day, you can have one artist create a script to process an asset, and then that artist scales to 1,000 people who can execute that pipeline and workflow. Therefore, we're scaling the resources, and those of us that are doing a lot of work for a lot of different people can now just let those people take it on for us. And going on from that, I'm going to hand over to Kellen here to talk about a pipeline in particular.
Thank you, Josh. As Josh mentioned, you can extend your spatial data lake with pipelines. With automated 3D creation pipelines for photogrammetry on AWS, you can scale your spatial data in a matter of minutes. But for some background, if you're not familiar with what photogrammetry is the science and technology of obtaining information from the physical environment as well as objects and from images. The photogrammetry process creates a number of output artifacts that can range anywhere from structure from motion data, point clouds, geometry meshes, as well as texture data. And the GIF you're seeing here is an example of the photogrammetry reconstruction process. But there are challenges, right? There are challenges to 3D creation. Even though our digital content creation tools are better than ever, they're easier to use than they have ever been, and they're more available, there are challenges to creating for 3D. And these challenges include that the 3D creation process is time consuming. It can take anywhere from days, weeks, and even sometimes months to turn around final 3D assets. It requires highly skilled individuals and teams with specialized techniques to create 3D assets. As well, it uses siloed workflows. Often our digital content creation tools use proprietary formats that don't necessarily communicate well between each other. And finally, it still requires high compute graphics workstations that are costly to obtain and maintain. But working with AWS serverless services, such as Amazon Simple Storage Service, or S3, AWS Lambda, as well as AWS Batch, which is our serverless batch compute service, as well as AWS partner photogrammetry solutions from the AWS Marketplace, such as 3D Flow's Flow Engine. You can scale your 3D data and create thousands of 3D assets in a matter of minutes. This is an example of that solution. Taking it a step further with event-driven pipelines on AWS, you can utilize custom containers running on AWS Fargate, which is our fully managed compute engine that allows you to run containers so that you can focus on developing your application instead of the cloud infrastructure required to run your application. And with something like this, you can create 3D assets using photogrammetry, but as well create other event-driven pipelines for doing things that Josh mentioned, such as 3D asset tessellation or CAD to XR optimization. So thank you. And I'm going to hand it over to my colleague Lauren to discuss AI/ML.
Thanks, Kellen. I can't see the screen. I can. I'm going to go through just a really high-level overview on some of the AI/ML services that we have at AWS to empower a lot of these technologies and things that Kellen and Josh were discussing, and that I'm sure that you've been hearing about all day. I'm going to start with Amazon Recognition. Amazon Recognition will use machine learning to analyze video streams, pictures, things of that nature, and it'll automatically tag them with what it sees. It has a set that it comes with, but you can train it to do more customizable sets, customizable labels on more complex things. But any kind of video or picture you can integrate with Amazon Recognition and use it to add data to your spatial computing data scenes. So you could take like your LiDAR scans and add an extra layer of information onto them automatically, and that saves a lot of time. SageMaker, I think a lot of people have probably heard about SageMaker, but I think few people have probably heard about it in this context. This is where we can combine the LiDAR point cloud data. And so all three of these things, so we're going to use recognition, point cloud data, SageMaker ground truth. And what that's going to do is that's going to take, specifically in this use case, take those LiDAR scans, take those point clouds and analyze them for, again, customizable sets or standardized sets. So a lot of times for recognition, it says, oh, we can recognize celebrities. It's like, well, if you can recognize a celebrity, I'm sure you can recognize this building that I'm telling you all about and giving you all the details for. So for in the less exciting use case of, construction or any kind of industrial nature, but you use it for fun stuff like amusement parks. They use a lot of photogrammetry and LiDAR scans to do, some of the virtual reality applications you may have seen or AR applications that you've seen at Disneyland, because Disneyland's not fun enough, so you got to have the virtual Mickey Mouse too. But SageMaker is kind of what pulls it all together and allows you to really benefit from the cloud and its processing power in that regard. How many of you have ever had to write a regular expression? Yes. How many of you have enjoyed that? Kimate's not a person, so his robot is a dog, right? So if for no other reason than to be able to write a regular expression for you, I love Amazon Code Whisperer. Amazon Code Whisperer is our real-time code generation. So when you go to, you can, use the little regular hashtag and say, hey, I need a function that writes a regular expression that, does all these things. It's like, I want a phone number, but not US phone number. And it's not, this part of the country that I want this part. And it's like a, 70 character long regular expression. And it writes it for you. And it's beautiful. It does a lot more than that too. But I think that's where I stop because I just get too excited about it. I was like, I can do everything else, but please just write this for me. It can help you learn new libraries faster. So I learned programming on C on Solaris machines a very long time ago. And so there's a lot of new language. We didn't really focus on object-oriented languages. So the Javas and the C-sharps, they're not new to me necessarily, but it's taken me a little while to get back into it. And you can start your program and it'll give you a lot of suggestions on how to not just write like a line, it'll straight up write whole functions, whole libraries, whole classes. And you still need to be in the loop, right? Because it's not perfect, but it definitely sets the foundation for you to kind of be like, oh, okay, there's this library that's available to me, or I need to integrate this library or this API. It's going to let you develop spatial computing applications quicker because for all those same reasons, the back end of a lot of a lot of our spatial computing is not, the imperative languages or the super complex ones. They're the object-oriented ones. They're using Java. And so a lot of the tasks that you need to do can be pretty straightforward. You just need to be smart about how you put them together, right? It's how you string them together that makes them more complex. And so with something like Code Whisper, it's gonna lessen that time a lot. We have a lot of anecdotal evidence to suggest that there's less keystrokes involved with Code Whisper, but Kellen gave us a little statistic yesterday that said, he wrote a whole bunch of Lambda functions in half a day where normally it would have taken him 2 days, or was it 2 hours? I don't know.
2 days, 4 hours.
4 hours, 2 days, that's half a day, right? My math is right there, cool. And we get that a lot. There's, scripts that you can write to investigate it yourself, and it'll show, here's how many characters are in your resulting code, and here's how many keys you actually hit. And the results are pretty crazy. So I should stop talking about it now, but I like it. Finally, Amazon Bedrock, which everybody gets very excited about, right? It's like that other thing that's out there that you can ask it questions about, and it'll write you stories. Bedrock is the same kind of principle. It creates it gives you these foundational models to use that you can build on. So we have first-party foundational models with Amazon Titan, and we also have it built on or have available to you some other third-party foundational models like Anthropic, it's the one that starts with an S. Stability AI. And so it combines startups and, again, our first-party solutions, and you can customize those, right? It's just a building block, but it does let you create things like going from text to 3D models. So instead of having to design something from the ground up yourself, I am not an artist by any stretch of the imagination, so I could tell it, hey, build me this model of, a building that's blue, and you can do all kinds of like silly stuff, like make me a chair out of an avocado, or something silly like that. But there are lots of practical applications as well, where let's say you were building a facility and you already have that 3D model, but you want to maximize the volume of a container that you're putting in it. You could say, hey, build that out for me. So there's all those things that are available with Amazon Bedrock. It's in kind of the early stages, and so it's not quite generally available, I don't think, but you can talk to us and we can kind of work through some of your use cases there, especially for spatial computing. Thank you. We will be doing some technical deep dives into all of the things that we've discussed today. Sometime we were going to put a specific date in there, but we didn't. So it'll be coming soon, sometime this summer, maybe early fall. It's going to be very in line with what you saw here. It's just going to build upon those things. If you have any questions, we have time for Q&A. And if you really love us, please fill out our survey and tell us how much you love us. It's 2 questions, takes 2 seconds, but it gives us some good data on how effective we were and whatnot. The end.
Test.
Are we good? Okay, there we go.
Okay. No questions? Cool. Bye. No, I'm just kidding. Go ahead. We got a question right here.
Oh, and whoever asks a question gets a T-shirt, and whoever else gets a T-shirt, I guess.
And Kamate raises his hand.
So does it do like remote rendering?
I'm sorry, what? I can't hear you.
Can you hear me?
Yes.
Oh, okay. All right, thank you. Does it do remote rendering of like CAD models and stuff?
So if you're talking about the visual asset management system,
Yeah.
there are ways to integrate that. It doesn't do it out of the box.
Okay.
So if you're talking about large models that you have tessellated, usually anything greater than 50 megs, I would say we would either need to render pictures or render remotely. just for
Right.
distribution purposes. But the thing about VAMs is it's open source. So you could do that integration yourself, whether you're using like NVIDIA Cloud XR, we've got tools like Nice DCV and AppStream that could potentially render straight to an iframe within that web page.
Okay. All right. Thank you.
You guys mentioned supporting photogrammetry. Are you guys looking into neural radiance fields at all?
We are, and that's something that, you know, since VAMs is open source, and with things like AWS Fargate, you can run any NERF library you may be using in something like a pipeline or built into VAMs, the open source project. But yeah.
And you can introduce yourself and your company if you'd like when you ask a question.
Hi, I'm Chang Hong from the SDA. I just want to ask whether you will be open sourcing the VAMs portion, the data storage portion as well, so that we can use our own data servers.
It's fully open sourced.
Okay.
And the data storage behind VAMs is built upon S3 and DynamoDB. So, you know, in anything you're looking to store, you can really store in those solutions. So it's kind of, you know, up to where you want to go with it and you know, what you can do with it.
I will note it's not limited to visual data either. We've stored CSVs, tables, et cetera. Just basically, we start that for all prototypes pretty much at this point, storing data, analyzing it, distributing it.
All right, thank you.
Wake up. You're almost done. Is that it?
Okay. So in terms of Whisperer, like, how do you deal with the whole copyright or other issues? Like, basically, with any generative engine, any code generative engine, you have copyright and other issues. So how do you deal with that?
With what issues? I'm sorry?
Copyright issues, basically, because of the code being reused.
Good question. I don't know the answer, but I bet one of these guys do.
I believe that Code Whisperer was trained on our internal code, so no other copyrighted code was used in the training of it. You know, so it should be safe. I would say reference the documents to verify, reach out to your AWS account manager, and have a conversation with an AI/ML specialist about the topic. You know, we're here for you. We're open to have conversations and just hope that you know, like to use the services.
Actually, now that I think about it, when you go to initialize Code Whisperer, there's a box you can check so it won't recommend attributable code, or so you can turn that function on and off. And then on the Code Whisperer homepage, there's also a link to all of the different licenses, not just for Titan, but for, it's got the EULAs for Anthropic and AI21 Labs and Stable, the main ones that are on it. So you can't turn it on and off.
There's also a really great blog written by one of our colleagues that's on the AWS AI/ML blog channel that dives deep into Code Whisperer and provides this sort of information as well as tips and tricks to using it.
I think we're getting the
Question right there.
One more. Last one.
It says we have 59 seconds.
When using a 2D photograph to make a three-dimensional model, do I need a reference model in order to map that on?
No, not in a typical photogrammetry process. You do need a number of images, right? An image data set And working with something like 3D Flow Engine, it expects that as an input and then goes through the process of aligning and registering those photos and then creating a point cloud and a mesh from those photos. I will say real quick, the really cool thing about something like a photogrammetry pipeline is that anybody who has a smartphone who can use the camera can create 3D models.
Thank you.
Thank you.